Hey guys, so welcome back to your next class of Catalyst Concepts. In the previous session, we started looking at Water-Square-House laws, what we called. We looked at one thing called the junction law. It's a pretty simple thing. Today, we are going to look at something called the loop law. This is a little more bigger than the junction law. Okay, so loop, let's look at the first word loop, right? A loop is nothing but one closed path, a whole closed path within a circuit, right? For example, I've taken this example over here. You see there's a big circuit, right? This is one closed loop if I look from the point of A, right? So we're going to be demonstrating this law with this circuit. So just we'll refer to that when the need be. Okay, so what the loop law says is, if you go across a circuit, you will see that there will be multiple components, right? You have like batteries, you have resistors. Uh, each of them works a little differently. Obviously, they have different functions, right? But based on which one it is, each component, what it can do is it can increase or decrease the voltage, okay, or the potential difference that we say. Okay, each component changes the potential difference, okay, across it, only across it. Like for example, if I'm talking about a resistor, the potential difference across it will be different from the one at a battery. Okay, now if I have to go across a circuit looking at the changes, I can say that the sum of changes in potential energy, okay, if I just add them all up, by sum I mean algebraic sum, you just simply add changes in potential energy in a loop is always 0. Okay, so basically if I add the changes in potential energy for all of these components in one loop, the total is always going to be 0, no matter what type of circuit it is. That is what the loop law says. Okay, so if I look at this circuit, if I talk about my loop starting from A, I'll go from A to B, B to C, C to D, D to E, and from E back to A. That is a complete loop from start to finish, right? Now, if you see, each point is taken keeping one component in mind. If I say A to B, it is only because there's one component, the resistor in between, R1. B to C, one resistor. C to D, I took the point D because there is a battery over here. And after the battery, there is a resistor. So that will be D to E. Okay. And from E to A, there's just one battery over there. Okay. So we'll take points between every one component of the circuit. Okay. Now, so the first thing that you have to do when you're trying to take loop law or demonstrate loop law is fix a loop. Okay, fix the path of your loop. So for example, you can either go clockwise or anti-clockwise. By clockwise, I mean like this, like how the clock goes, and anti-clockwise means like this, in reverse. I generally take clockwise, so you can just go with clockwise also. I'll be demonstrating with clockwise. So if I go clockwise, basically I'll be starting from A and going like this, meaning from A to B, B to C. So I'll just write the name A, B, C, then D, then E, and then from E I'll go back to A. That is my loop, A, B, C, D, E, A. Okay. Now I have set the path of my loop. Now, once I have set the path of the loop, I will be taking a close look at what exactly are the different voltages for each component. Okay. Now, you will see that when you talk about voltage, we know the formula V equals to IR. Okay. So if you are talking about the voltage of the battery, you can directly use the battery volt. So if you look at my batteries, it's given V1 and V2. So the voltage of my battery I can directly give as V1, V2. But when it comes to resistance, I'll have to use this formula IR. Meaning if I'm using for this third resistance, I'll say I into R3, which is the third resistance. And for the first one, it will be I into R1. Okay. So for each one, we calculate it separately. Okay. Keep that in mind. Now, when we calculate it, we need to look at something called the sign convention of calculating. Okay, we're going to look at sign convention. Basically, is it positive? Is it negative? What is it? We need to see. Okay, now how does the sign convention go? We'll start. First one is we'll talk about batteries. When we talk about the battery, if your path is from negative to positive terminal, then you'll take as positive voltage. Okay. If you're going from the negative to the positive terminal, you'll take it as positive voltage, and the opposite. If you're going from positive to the negative terminal, I'll take it as negative voltage. Okay. How we use this, will come to that. We'll actually just take a look at that. Now look at the path of my loop. A to B, okay, there's no battery. B to C, no battery. C to D, there is a battery. Okay, this is my path right now. When I'm going from C to D, I am going from positive to negative. Correct? Positive is the big side, negative is the small side. Since I'm going from positive to negative, my V1 is nothing but as, I'll take it as minus V1. Okay, I will be taking my voltage for first battery as minus V1. Okay, same way when I go from E to A, I am going from positive to negative. So I'll again take as minus V2. Okay, you just need to look at the direction, positive to negative. The end direction is the answer. All right. Now, that is for this thing. When we come to the resistors, which is the next component, what we are going to do is we are going to compare with path of current. Okay. Compare with current, which is nothing but I, for resistors. Okay. Look at the current. For battery, you don't need to worry about current. Okay. Now, when you're looking at current, if you are moving in same path as current, okay, same path or same direction, then you will take it as negative voltage. Okay. And if you're going to opposite direction, I'll just use the word direction instead of path. Using as the opposite direction of current, you'll take it as positive voltage. Okay. Meaning, for example, if I'm going from A to B, I'm going over R1 in this direction. But the current is coming from B to A in the opposite direction. Meaning, since we are in opposite directions, I will take this as positive. Okay, I'll take that as positive voltage, which is nothing but plus I into R1. Okay, if we follow these rules, then we can very easily get all the answers. Okay, we'll just try to demonstrate real quick and finish this off. Let's start from this loop. Okay, so the name of the loop is A, B, C, D, E, A, right? All right. A to B. If I'm going from A to B, this is my path of movement, but this is path of current. Okay. This is current. This is AB, which means for R1, I will take it as positive. So I'll say plus IR1. Okay. It will be For AB, I'll just put it like this. For AB, I'll take plus I into R1. Okay, which is nothing but voltage. Now, I'm going from B to C. Okay. Now, in B to C, my direction is this way, moving downwards. Okay, but the current direction is from C to B in the opposite direction, like this arrow is showing you, right? Which means we are again in the opposite directions, which also means again that my voltage is positive over here. Meaning from B to C, I'll say plus again, but I into R2, which is the second resistance. Okay. Now, what about C to D? Okay, we already saw C to D. In C to D, it's just a battery, so we don't care about current. We are moving from positive to negative terminal here. So I will take it as negative of voltage 1. Okay. Next comes D to E. D to E is again a resistance. This is my direction of movement for my D to E, and the current is in the opposite direction, right? Meaning it is positive voltage I into R3. Finally coming to E to A, which is nothing but this direction, and that is just a battery. So only positive to negative movement, which means negative voltage minus V2. Okay, so this way I have calculated using the sign convention for all 5. Now the law says what? Algebraic sum has to be 0, meaning I'll have to just add all of these together. So I can say I into R1 plus I into R2 minus V1 plus I into R3 minus V2 equals to 0. Okay, this is one big long equation. The sum of all of these will definitely be 0. It doesn't matter what expression you get, you just need to write that as equal to 0. You generally don't get any sums where you are given values and asked to calculate. You will be asked for this expression specifically. Okay, so this is your loop law. Just to recap, there are 4 major sign conventions here, 2 for your battery and 2 for your resistances. In which direction your loop is going is for the battery. And again, compare your loop to your current flow for your resistances. Okay. That's it for today. I hope you understood. If you have any questions, doubts, please drop them in the comment below, and I will see you again in the next class. Thank you.